Hi there, this is my virtual camera control system I designed. It uses an Arduino that sits inside of here to send control commands to Unreal Engine 4 to drive the virtual cameras in there. This is all it is, it all sits in there. Alright, so I'm going to tell you about exactly how I came about to design this, what was inspirations for this, why I did it, processes involved, and everything else that is associated with that. So let's get into it. It all started off with me looking at existing camera control systems for virtual production and looked at a few different people and what they were doing with it. There's quite a number of really talented people on YouTube that are essentially sharing what they're doing in their developments and stuff over time. So I looked at Matt Workman and I looked at his really cool setup for virtual production, and he uses a Xbox controller essentially to navigate around the scene, position the camera, and then he picks up his control rig and uses a variety of different methods to control the virtual camera. And then you've also got Jake Water, who is doing similar stuff to Matt Workman, and he's using things like follow focus systems to control lens focus and also zoom. And then you've also got Aidan Wilson, who's also doing some interesting stuff from Australia. And all of those generous people who are sharing their work tend to be doing a lot of camera control stuff using things like Xbox controllers or game controllers, and also mouse and keyboard, just to do the majority of the positioning of things, and then using things like HTC Vive trackers to track the local positioning and the rotation of the camera, but also using some of those trackers to deal with identifying camera lens zooms and things like that, right? So I thought there must be an easier way, or a way that you can kind of integrate all of these things into one object. And in the back of my mind, there was also this issue of synchronizing lights inside of the virtual space, but also with the physical space. And I know that the common high-end solutions to this is using a LED, light stage essentially to match the virtual lights with the physical lights. However, on an indie level, it's not that easy. I've seen some examples of, matching up the virtual light with a physical light in the same positioning, and turning them on and off as the scene changes. But one thing that's really cool is you could use something like an Arduino to essentially drive physical lights. You could use that to drive motors. You can use Arduinos to do lots of different things. And I thought, couldn't you just use an Arduino to drive Unreal Engine as well as physical sensors, motors, lights, electronics, all that type of good stuff, right? So it got me down this rabbit hole of experiencing something that was quite fun, quite engaging, quite frustrating. And early stages, I tried to get one of these working with Unreal Engine, and I did that pretty well. However, I did struggle with getting everything in place. So let's have a talk about exactly what process I went through, the prototyping of just connecting this with Unreal Engine, and then we'll go into the prototyping of the actual physical controller and the decisions I made and exactly how it works. So let's get into the Arduino and UE4 side of things first. So I'd already been playing around with the Arduino and UE4 link previously, and I've been documenting some of this process on my blog, and some of that was quite simple. I mean, one of the very first prototypes was to get a light sensor inside of Unreal Engine to dynamically change the light inside of the engine just by kind of covering your hand up over it. But I started going to more and more kind of challenging things, inputs into the engine, outputs out of the engine. So for example, if you triggered a certain point inside of the scene, then it would move essentially like a stepper motor, or some sort of like a servo motor or something, just to trigger something in the real world. So that was going quite well, but one thing I hadn't cracked at that point was, how do you drive multiple inputs at the same time to do lots of different things inside of UE4? And just at one point something came to me where I could string everything together as to one essentially command line that you could use to control the things inside of UE4. And previously what I've been doing is I've been writing to each line and then pulling that in, but the problem was there was a bit of instability with the different values clashing with the different operations inside of UE4. So one point it came to me just to string them all together into one line, send one line every single tick, and then essentially take that line and split it up into different areas. So that was kind of the breakthrough point for this project, where the idea came to me and I thought, okay, well, now I can do this. So I assembled a breadboard and I put lots of different sensors on there. So I had 3 potentiometers, 2 buttons, I had 1 light sensor, and I think I had one other thing in there. But essentially what I'd do is I'd set up a test bed of a simple scene, and I would test it out. And the core functions at this point were to do with the camera zoom, camera focus, camera aperture, and toggling between different cameras and things like that. And I was using the UE4 Arduino plugin from Rodrigo Villani, and that plugin seemed to be quite good with 4.26, the latest update. However, it was lacking some versions, and near the end of the project, unfortunately I found this at the end of the project would have been better at the start. I stumbled across a rebuild from Ramiro Monte de Oca. I probably pronounced that terribly, but he rebranded it, he named it Serial Com, and he's updated it for 4.26, 4.27 and UE5, which is really cool and something that I'll be using moving forward. And he's doing some really awesome stuff with that. I've got to really look at exactly what he's doing and see how I can tap him for knowledge. But I essentially made sure that I could send a whole series of commands at the same time into UE4, splice them into different areas, and then you read those areas or those variables to drive different things like the camera zoom, camera position, etc., etc. At this point, I'd done some prototyping in the VR or mixed reality suite Staff's Uni, and I found that obviously because the breadboard was a big kind of pile of cables and things, it wasn't user friendly enough. Part of the objective was to be able to pick up the controls and move them around with a camera tracker, and I had a colleague that got zapped by one of the components. So I think at that point it was really obvious that we needed to come up with a robust kind of control system, something to hold on to it to shield the user from all the cables, to make it more usable, and to figure out a way to mount the Vive tracker. But there is a lot of footage of me testing this out. I am trying to figure out exactly if it works, any potential issues, the blueprint side of things as well, we'll explain that. And at this point I was probably around the time where I was thinking, okay, it would be good to push this further and move those cameras around in the scene virtually using joysticks like you would with a gamepad. Right, this is the perfect time. We've got a proof of concept. It works well on the camera controls. Let's start moving the camera around and controlling everything else, and then let's get an enclosure working for it and tracking the spatial kind of thing with the Vive tracker. So at that point, we've done a lot of stuff in terms of Arduino sketches, blueprint stuff, and got the controllers working. It was time to push that further and get some kind of good outcomes out of that. We're going to have a look at the sketches, we're going to have a look at UE4, we're going to talk through the blueprint, we're going to showcase exactly the functionality of it inside of the mixed reality suite, and we're also going to show the final product in action. And then what we're going to do is we're going to go into the product design side of things, learning Fusion, and all the other associated 3D printing manufacturing processes. So we'll leave that there. So looking at how this works, we're going to start off with the sketch that we've created. And obviously throughout the process of development we went through a few different iterations, and I do have saved versions of these. However, just to save a little bit of time, I'm going to look at the final version that we've ended up using, and I'm sure there's more optimizations in here that we're going what we could do. But essentially what we do is we establish all the variables and on each controller they're identical, but they're just mirrored, right? So on each controller we have one potentiometer that controls either the focus or the zoom. We have one joystick which has got X values and Y values, but also a button attached to that. So we can see here we've got the pop pin one which is the focus or the zoom, we've got the X and the Y value of the joystick, and then we have a button that's associated with the joystick as well. And then adding to that, we have one additional button on the controllers, and that can be mapped to whatever we want. It could be a camera toggle, it could be some sort of a reset button, it could be some sort of a toggle to change different settings. There's lots of different things. So there's a few different functions on each one. There's 2 buttons on each side, one joystick and one potentiometer, and all these values are essentially established at the start. We do have some different states in there as well, so on-off states, and we have toggle states and kind of status checkers as well. So we initialize each of the buttons in here, so the joystick button and the extra buttons, and we also have this set to a baud rate of 19,200, and I find that 19,200 works really well with quite fast scenes, or if you've got scene with high frame rate, it'll work really well. However, if you have a scene with a low frame rate, it will start essentially queuing everything up in a backlog, and while it still runs quite smoothly, it's just very delayed. So there's a balance between the baud rate and the frame rate inside of the engine that needs to be considered moving forward, and that's something that's going to continue carrying on into the next stage of the project. It's still unanswered at the moment. I'm sure there's a better way of sending all these values from the controllers. So essentially in here we go through, we read the values and assign them to variables. You can see that here, and then we run it through this function called add zero function if it's a potentiometer or a joystick. Now what that essentially does is it'll standardize the values that are being read into different blocks of 4 characters essentially. So let's have a look at it down here. It's right at the bottom, so it feeds in the value. If the value of A is less than 10, well then it's going to add zeros on there. So if it's a value of 1, 2, 3, 4, 5, it's going to go 0, 0, 0, 1, 0, 0, 0, 3, 0, 0, 0, 5, and then we reduce that down. So obviously if it's a value of 10 to 99 or something like that, it'll add 2 zeros on the front, so 0, 0, 10, 0, 0, 99. And then the same, obviously, if it's a value in the hundreds, we put a 0 on the front. Anything higher should automatically take up all zeros as well. Right, and by doing that, we ensure that we always have 4 characters to each potentiometer and joystick. And what that does, in essence, is it reduces or it prevents the string from getting shorter or longer, and then therefore when we do an index check inside of UE4, we're not getting an incorrect value. So essentially what we do is we feed through, and anything that requires 4 characters, we run it through that function and then append it to this current string. So previously what we would do is we would have just printed straight to the command line and then appended that inside of the print process and then created a new line to reset it. I found that if there was a bit of a desynchronization between the Arduino commands being sent and UE4 reading them, sometimes it would truncate that line, therefore causing a lot of different problems. So as an iteration of that, I decided if we can bring it all into one line and then print the line, there was no chance of it truncating that line and causing issues with the sensors. So yeah, we cycle through all the different controls, and at the end we just basically print that line to the COM port and then just delay it a little bit. Now we could always reduce this delay and see what happens. I haven't actually played too much around with this. This was usually just to make sure that things weren't getting too laggy inside of UE4. There is a natural delay between the sending of commands between the two. So that's something, it's 5 microseconds. It's not much at all. So it's just a tiny bit. But it's, in essence, I've got it hooked up right now. So if we go into the serial monitor, you'll see this is what we're getting. And the first value is the left potentiometer. You can see that's changing as I go up. The limit of around, it's supposed to be 1023. Not quite hitting that. Right down to 0. And then the next block, so if I put this at top value, you can see 0503. That is the X value of the joystick, which ranges between 0 and 1023. And then the next slot is up and down, so Y, 1023, 0. The next one is a button of the joystick, so if I press that in, it'll toggle off, and then press it in on. And the next one is the other button, so you can see its default is off. Now it's on, off, on, right? And the same is on the other side. We've got the potentiometers. See that? Joystick, values, up, down, left, right, button on, off, and then the other button on and off, right? So each of this is sending straight to the COM port and bringing it into Engine. So if I close this off and come over here, and this is what we've got here. If I play it from here, you'll see that we have a serial read line and we've got the return value, and that exact string is coming in and being used, right? So now you can see this in action. I'm flying around the scene. It's quite responsive in nature. I can go up, I can go down, I can go left and right, forward and backwards, and I can rotate around. Any type of tilt that's going on will be done using the HTC Vive, and any rotation of the camera is the HTC Vive as well. So we can get minor control over this, but there's a few different things we can do. So we can play around with aperture values. So if I go in, let's go and do this. I change the focus. I can change the aperture value. I think it works better with the other controller, to be honest. So this is the aperture value being changed, I think. And we can, oops, it was being changed before. Okay, it's not, there we go, there we go. We can focus, we can zoom, we can position our camera and zoom in, and now we can probably start getting some aperture sensitivity going on as well. All right, so there's a few different things we can do just to get things working quite well. We can also reset our values, so it's resetting to the center of the stage. So I can do that again, we can reset it. We can toggle between different cameras, we can reset, and we can also open up our take recorder as well, right? So there's a lot of different things we can do to gain that extra control using this, right? So let's explain exactly what's going on inside of the blueprint. What's happening is on tick, we check to see if the Arduino is connected, and then from that we'll read the line, and you can see it's reading a line here. Now we want to check that the length of the string is around 28, right? So that's all the sensors combined, that's how many characters we're expecting. So if that length is correct, well then it's going to execute this. If that has any issues, maybe the COM port truncates it, and then it's going to reject it and do nothing, right? So previously, before me modifying the actual way that the Arduino Sketch worked, it would always trigger false when it was essentially just truncating it by accident, right? But from there we can split this up into substrings, and you can see obviously we're going to start from 0 and go to 4. So the first one is the Arduino zoom, and then the next one is the joystick control, joystick control, a button which is one length, and another button, right? And we do this, we kind of get the indexes and we specify the length, and then we assign those two values, and it only happens when it's being updated. So if we go over here, we can see I'm going to use the camera zoom here. The zoom isn't working at the moment, but if I start zooming, you can see it triggers that, and then it sets the camera zoom property inside of the variable. It does check to see if it's being changed or not, but once it's triggered, it'll trigger an event dispatcher inside of the main program, right? So each of these is assigned. You can see that some of these values are a little bit sensitive. So if you go to the actual return value, if some values are just kind of tweaking out a little bit, you can see they just kind of toggle between two values. We've tried to smooth that out using capacitors on the board, but it's not 100% working. But it's minor, right? So each of these go down, they check to see if the buttons are on or off. You can see the buttons are being toggled on and off. And then what they do is they trigger something in the main sketch. So this drives everything. There is some settings to do with activation of the port. So it activates the port, sets the baud rate, just make sure that it's connected before it does anything, and then it closes the port once it's done, right? So all of this is just kind of triggering different updates on the controller, and then essentially actioning certain things in the main script. So if we go into the main blueprint, this is being done in here. Just give it some more space. And there's a few different things happening here. So first one is on setup, we essentially assign the camera to a container, right? And if we don't have, the reason we do this is we don't want to deal with the local translation and rotation of the camera. We want to do it on the container so we can reset that container. The camera is being controlled purely by the HTC Vive tracker in LiveLink, so that must be driven by that, and the container can be driven by our joysticks, right? So we put the camera in a container and we snap them together, essentially. We do a bit of a delay, just making sure that the Arduino is initialized before we start the ticking event, otherwise the camera just drifts off to nowhere. So we do that, and then we kind of just set it all. We set the main active camera and the one that we want to look through, and then we bind all the events to lots of different things, right? So we use the camera zoom dispatcher, focus, left stick, etc., etc., and these trigger all these events up here, right? There is another one that happens on tick. So the camera work, so the camera movement, translation, position of X, Y, and the Z value, and then the rotation are all done here. This is something that can be optimized a lot in the future. You can see how we've done some manual math to try and crunch it all down. However, I do want to use this range clamped. So the problem was earlier on, we struggled with centering it off. Essentially with a potentiometer, you have a value between 0 and 123. You want it to, as a default, start at 0, and then if you move left, it goes in negative space. If you go move right, it goes in positive space. That's not needed there, and that's not needed there anyway. But we wanted to put it at 0 first and then range map it. I haven't done this yet, so the problem is obviously the range map is incorrect, right? But we can optimize this, probably some potential gains in really small amounts, but all this controls the camera position and rotation with a local offset of the container itself, right? Local offset, local rotation, then we can reset that with the reset button. Up here, got a few different things. We just get the values, and we can deal with your camera zooms. We can also control, obviously, if the left stick button is on, well then we want it to trigger the aperture value. If it's off, well then we want it to deal with the focus. So we can use the toggle buttons on the joystick or the main controller to essentially toggle between different settings that we want to change, which is kind of cool. Range map didn't really work here. I haven't plugged it in for some reason. I don't know why it's disconnected. We can fix that up later. But we've got a zoom event, we've got a focus event, we've got an aperture change event. You can see here it gets that and triggers all this with a range map. So we can expose these values and have these in a tool that we set, so we can set our minimum and maximum aperture range for our camera, which is cool as well. There were some legacy like toggle events that we had in there, which obviously I've named them incorrectly, but this one is a reset. So we grab the container, we reset the position, we grab the camera, we reset the position and rotation. We've got some toggling between different cameras. Ideally, this can be also put into a different tool, so we can set the number of cameras, automatically generate the camera, attach them to containers, and have all that done. And then obviously this one was a testing prototype where we toggled light intensity, right? So there's a lot of different functions in here. We can create our own functions, what we want the cameras to do, but it's all driven by updates on the sensors that are reading real time on tick, right? So that's roughly how it works. You can see it kind of works quite well. You can see that for the most part, when it's not kind of dancing between two different values, it will kind of bypass some of these updates. You can see there I'm pressing the button there. On the other one, I'm pressing the button at the bottom. But you can see as I use the controller, it all kind of updates as we go. All right, so that's pretty cool. Works pretty well. There are some bugs with it, and for some reason it works better if I just hover over this and it's always updating, which is a weird kind of quirk it's got. But on the whole, we've got some really nice controls that we can play around with, and different cameras we can work with as well. All right, so some really cool stuff going on. So we can have different cameras, we can position them up, we can have different zoom properties, focus in on things. It's all quite nice. And the good thing about this is you can use this as a tool that doesn't require an actual camera for syncing. So if you're just using virtual production for your own presentation of the scene, we can get that nice kind of movement in there if we want. All right. Just takes a bit of practice. So there was 2 scenes I worked on. This is one scene, and it's a simple one that works pretty much on most computers. It's quite optimized. However, we were working with a sample scene, if I can find it. Might be this one. Yeah, it's this one here, with a bit more of a higher fidelity kind of result here, right? So let's have a play of this. Let's see how it performs. At the moment, we're at 50 or 60 frames per second, and we're running at a pretty high baud rate. So this is it in action. And it's a little bit laggy when you're in the open areas like this. When obviously I'm recording a video at the moment, so it's a little bit struggle town. But it's not very responsive at some point. So if we drop the performance of this, let's just change the settings to not cinematic and maybe go to high. Might get a better frame rate here, and we might get a more responsive kind of outcome. So there we go. We've got something that's a little bit more responsive, that works quite well. So the camera controls are all inverted for some reason. But we can get some nice zooming in here, some focusing, and some lots of different kind of controls that we can play around with, right? So we can do some nice stuff on some pretty complex scenes. We've just got to be careful about the frame rates that are being actioned. Oops, it would help if I didn't have inverted controls in this version. That's all right. We get there. Cool. So overall, I think it's been pretty successful with this bit of the project. We managed to get it working. That's roughly how it works. It's all about reading the serial line, splicing it up, assigning it to variables, and then using those variables to drive different parts of the scene and the camera. So hopefully that's informative, and I will leave it there. So when it came to the prototyping of the actual controller, we started from pretty simple starters, essentially. One thing I wanted to do was I wanted to get a sense of the ergonomics in the hand and how it would feel to use a controller. And one of the most chunky components was the joystick here. So that joystick stuck out pretty far, and I thought, okay, well, if I embed this into a bit of leftover cardboard that I had from some product packaging, I could probably get a good sense of exactly how it would feel to hold and navigate. So one of the very first prototypes was literally just a piece of cardboard with that cut into it and secured to some wires, and this served okay to hold it in the hand and ensure that the orientation of the X and the Y on the joystick was correct. But from there, it was pretty important to rapidly move into different stages. So one of the things that I took inspiration from, I was looking for industry examples of controls for things to do with cameras and things like that. Was essentially like a Steadicam or a camera gimbal, and I had one that's in my container back there. But this is one of the parts of it. Right, so this secures to the actual gimbal itself, and it's got a bit of a joystick on the front. You can see that there. And I thought, okay, well, it's got a joystick there, and it's also got a button on the back. It could be a good reference to start from. So I went ahead and started measuring up this, and then going into further cardboard prototyping, which started leading towards this. And I got the dimensions a little bit wrong. It is a little bit bigger than I expected, and I could tell that from early rapid prototyping when I was putting it in my hands. I felt like it was a little bit too kind of large and chunky, especially since I felt more comfortable with the grip going into the back of it than around it. And then to add to that, I knew I needed that potentiometer to control, and I thought, okay, what's the positioning of it? Maybe I'll put it on the back because there's a button on the back of this. Maybe that's the best option. However, I took inspiration from another controller, which is the DJI drone controller. And you can see here with that controller, you've got 2 joysticks here. They control the 3D orientation of the drone in the air. But also on the top, you've got a rocker control for things to do with the camera zoom and such as. And when you hold it, it's very ergonomically placed and very comfortable to use. So I thought, okay, well, we can integrate that into the controller, and part of the early prototypes was to do with trying to put a kind of access to a potentiometer right there. So we went forward with some of those designs, and we went through the actual 3D printing process. So as part of this project, I learned Fusion 360, which is a CAD software, from scratch. I'd never used it before. You'll see some prototypes popping up on screen, but as I went through and prototyped some stuff and 3D printed them. So this is the very first iteration of that 3D print. Very thin in nature. However, I started engineering in buttonholes, button controls, tried to do some ergonomic grips, which are very simple at that point, but also some caps to this, right? So this was the top slot. And I quickly realized that after I put it all together, that the alignment of some of the components was incorrect, and I needed to do another version of it. However, on the whole, it did kind of fit together quite nicely. So I took that, and it went in through, once again, through a different couple of versions. Here's another 3D print of it. I'd never used a 3D printer from resin before, and it was really important that I got my head around that, so that was part of the process as well. But this is a thicker version, some more alignment issues or corrections on this, and some hole corrections as well. I was always thinking about how I could manufacture this and how it could be assembled, and then you know, how everything was mounted inside as well. So that version was starting to get a little bit more accurate, and from there we needed to work on a few different versions to increase the ergonomics. And there's this picture on the screen right now. I got really lucky with some rough assembly. I taped together the latest prototype version, and I essentially used some elastic bands to secure in the sensors. Primarily this was just to make sure that I could do some testing of the components and make sure that the project still worked. However, in that process I found that the angle applied to the potentiometer actually worked quite well, and it was quite ergonomically pleasing in the hand. So I picked it up and tried it out, and I felt quite comfortable getting the full range of motion on that potentiometer, right? So if I come back to the drone example of the DJI drone, this has a rocker potentiometer, and they're difficult to find. I couldn't find any, so therefore this kind of forward and backwards approach didn't work. I needed to have something that had a fair bit of spin. With it being an exposed wheel on the top, it was much easier for me to get my finger around a circle and complete the circle in a smooth kind of fashion. So we stuck with that, and we did a few different iterations of that to get to this final product. Now, this final product obviously has different versions. This is the first version. The button here is not very prominent. It's not easy to click, but it's there. The second version is much more prominent, much easier to click. I've adjusted some of the holes, the way it's mounted, and then from that we've managed to get to a point where it's quite sturdy. The screws in there work pretty well, although it is still taped together. We want to make sure that obviously it doesn't go anywhere. So there is still some engineering that needs to be done on this project and this controller. However, on the whole, it does mount quite well. And then the next stage was to create the housing, or the mount for the Vive tracker, and that was quite straightforward. I knew that I wanted to hide the circuit board in there and make a control hub. So the engineering side of things was done quite rapidly. We went through a few different iterations of that, and we started off with basic primitives such as cardboard and evolved that into 3D prints from different designs, all taken from inspiration from things to do with like drone controllers and camera gimbal controllers, but also looking at different controls from like gamepad controls, and another one which is a tilter follow focus. So I started looking at professional follow focuses that are used in industry and use them as reference as well. All right, so through that process, it was quite a fast-paced print, try, test, evaluate, identify issues, fix those issues, do the next version of it. Luckily, in the early stage engineering, I think I got a little bit lucky with estimating distances. I didn't really have to change too much. So, for example, this little housing for a pre-provided switch that I had, which is this one here, this little button here, that would slot directly in there. I got lucky with the slot working quite well. I had to change some alignments of holes and move this down. You can see that the later versions of this are further away from the original one, so that's the hole there, and that's the bigger one, to account for aligning both the joystick as well as the button inside of the housing and mounting it correctly. I got lucky with all that. I didn't have to do too much excessive changing. If I was continuing this, I'd probably do even more. On the flip side, I had to do some circuitry as well. So I wanted to create a minimum amount of cables. So the first version of this had a lot of cables. The next version I wanted to have as minimal cables. And as you can see here in the final version, we have one cable coming from this, one cable coming from this. All right, so we've got two to the central hub, and then that one central hub will output one cable to the computer. So I wanted to optimize that as much as I could, and as such I needed to develop some hubs. So there was one PCB, so circuit board hub, that belonged inside of each controller, which took all the sensors, combined them onto one sensor or one kind of hub, and outputted one cable out of that. And I went through a couple of iterations of that. You can see this is one that was failed. I made a mistake on this, and as such it's junk. But I created my own PCB boards from scratch. So I hand cut them out, I etched them, I drilled them, I soldered them, I did everything. I also developed my own circuit boards. So I used a program called Fritzing, which is quite used in the electronics area, and I created my own custom circuit boards based on my breadboard experiments. So I did that for each controller, and I also created a main hub for the little Arduino chip to sit in. So the cool thing about that, personal thing that I think is cool anyway, is that I can pull this out, I can reuse it on another project, and when I want to use this project again, I just put it back in, load the program in, and we're good to go. So everything's kind of modular in nature, and it should be good to go. As such, you know, we put it into practice. I can mount the HTC Vive tracker onto that quite nicely. Minimal cables, one cable into the computer. There are opportunities to optimize this even further, so we could start looking at using a wireless kind of pathway or some sort of a Bluetooth dongle. That could be really good, and a battery attached to that. That would be really good. So if I'm looking at the ergonomic form of this, let me pick this up again. There are a couple of things that I would like to add to this. So here we got our controller. I would like to have obviously the Vive tracker there, but also a monitor sitting here. I would like to have a space for camera to be mounted as well. So ideally I can mount a camera there, I can put a HTC Vive tracker on top of that, I can have a monitor that sits there that views the virtual inputs, and I can have it an all-in-one system. There may be opportunities for me to extend this into a shoulder mount, which will allow me to have a little bit less weight in my arms. At the moment, if I have that as carrying a big camera plus a tracker plus a monitor, it might get quite heavy, but there is opportunity to maybe potentially have one coming out here, one coming out here, rested on my shoulders, and I'm good to go. So I'm quite happy with the way that went. It went through quite a few different design iterations. I learned a lot. So I learned Fusion 360. I did some more PCB development. I learned how to do stuff within 3D printers and slice it up and print it out. I learned more about electronics. I learned about mounting and connection of different things, and I learned a lot in the process. So I went from having an idea, doing the prototyping, ensuring it works, coming up with a solution, and testing it out. And hopefully this is something that will be very useful in my next kind of coming projects, where I'm looking forward to putting it into an actual camera, controlling the camera via the Arduino, controlling things like lights with the Arduino, and having something that is completely controllable in a nice little package that's quite easy to carry around, and it's responsive in nature. So hopefully that's interesting. Hopefully you found that interesting, and that's it for the project. So cheers, I'll see you later.